Hey guys, welcome to the video for solving systems by elimination. This is in Unit 5. Our essential question is, how is the elimination method used to solve a system of equations? So Unit 5 is about systems, and we've learned how to solve systems a couple different ways already. The first way we learned how to solve a system was by graphing it. So we would graph the system, right? A system, again, is two equations. So we graphed the system. So for example, in this problem here, we graphed the two equations, and then we were asked to solve it. Well, when I'm asked to solve something, I'm asked to find the solution, where the solution is the point where they cross or intersect. So I can graph it and find the solution that way. The second way I learned was using substitution. I'm given two equations and I'm asked to solve the system. Well, instead of graphing, I can just use substitution. And using substitution is the second method that we learn. So you can either graph the equations or use substitution with the equations. And this is going to be the third way we learn how to solve a system, is by elimination. So our essential question is, how is the elimination method used to solve a system of equations? And so we're going to talk about what eliminate means to us first. So when we think about eliminate, we think about get rid of or take away, right? So we want to get rid of it. We want to take away. Well, in math, the only way to take away something is if you have the opposite of it. So for example, if I have 3x and I want to get rid of 3x, what would I have to do? I would have to subtract 3x, right? I'd have to have the opposite. If I have 3x and I want to take it away or get rid of it, I have to subtract 3x. Or another example is, if I have negative 5y, how do I get rid of that? Well, if I'm trying to get rid of a negative 5y and make it 0, I would have to add 5y to it. So I'd have to add 5y, and those eliminate each other, right? So opposite signs are what eliminates things. So if you want to put that as a note, opposite signs eliminate terms. And what else? Well, we have to have the same number, right? Because 3x and minus 2x doesn't make it 0. We need to be the same number as well. So we need the same number, but opposite sign. Okay, so for elimination, if we want to solve it, the equations need to be in standard form. And no, that doesn't mean we're going to have to do all this math to get it to standard. We just want it to have our x term first, and then our y term, and then the number. So we want ax plus by equals c. We want the x to come first, then the y, then the number. If the y comes first, I want to switch it so that x is in the front. So for example, if I have 5y plus 3x equals 7, I want to switch it around so I have 3x plus 5y equals 7. I want to switch it so that x is in the front. So that's what I mean by standard form. Just keep x in the front. Okay, so like with all of my notes, I always start off pretty easy. So in number 1, before we start, notice how my equations are stacked up on top of each other, and that's what we want. Okay, now the first thing we want to make sure is, are these equations in standard form? Well, if I look at the first one, yes, it's in standard. And so is the second one. They're both in standard form. Now remember back in elementary school when you guys would do addition and you would add and you would go up and down, so you do 8 and then you get 3? This is kind of like what we're going to do today. But before we actually add anything, we need to check, can I eliminate something? And you want to eliminate by looking at it vertically. So if I do x and x and I combine those, does x plus x become 0? It becomes 2x, right? So that doesn't eliminate. Well, let's check the y's. Plus y and minus y. Will that eliminate? Yeah, because if I have a positive 1y and I take away, I have positive 1y minus 1y, then it becomes 0. So this does eliminate something. So I want to check to see if I can eliminate something before I put my addition sign. And if I can, then I'll draw my little addition table. Now when you do the addition table, you want to do it vertically. And I always start on the left side. So we're going to start over here. Well, x plus x is going to be 2x. Okay, and you're always going to add. This sign here is always going to be plus. You never want to put a minus sign because it will mess things up. Okay, and then we have positive 1y plus negative 1y. Well, that's going to eliminate. It cancels. That's why it's called elimination, because you're eliminating something. And then you keep going. 12 plus negative 8 is going to be positive 4. So now at this point, all you have is 2x equals 4. Well, how do you get x by itself? You divide both sides by 2, and you get x equals 2. Is this our answer? No, right? Because even with graphing, it's going to be a point. With substitution, it's a point. We're trying to figure out where these two equations cross. So if I have the x variable, now I got to find the y variable. So what does that mean? I need to pick one of my equations. Does it matter which one I pick? No. So let's pick the first one. So the second part of elimination is basically substitution. So you're picking an equation, and you're going to use substitution to plug in what you already know. Well, I know that x equals 2. So I'm going to plug that in for my x because it says x equals. I'm going to plug it in parentheses. Okay, and I'm trying to get y by itself, so I would subtract 2 on both sides. And I get y equals 10. So what does that mean my solution is? Oops. My solution is the point 2, 10. That means if I were to graph this in Desmos or on a graphing piece of paper, they would cross at the point 2, 10. So elimination is just another method, right? Sometimes you can do substitution. If I did substitution with this problem, I would still get the same answer. If I were to graph this problem, I would still get the same answer. So sometimes you're given all these choices, and you can pick whatever choice you want, but sometimes some are easier than others. All right, let's go on to number 2. Now, number 2, I want to look at my equations here. The first thing I want to check to see is if they're in standard form, and they are in standard form. Then the next thing I check for is, do I have the same number anywhere? Because remember, in order for things to eliminate, they have to have the same number in opposite signs. So do I see the same number anywhere? I do. My y's have the same number. And do they have opposite signs? Yes, I have a +5 and a -5, so those are going to cancel each other out. So since I know that I can eliminate something, then I will put my plus table. But I don't do that until I check to see if I can eliminate something. All right, so I have 7x plus -4x, which is going to give me 3x. Positive 5y plus -5y is going to give me 0, right? It's going to cancel, it becomes 0. We have equals 26 minus 17, which I believe is 9. Yeah, 9, okay. Now I'm trying to get x by itself, so what do I do next? I would divide by 3, and I get x equals 3. Is this my answer? No, I'm trying to find my point, right? So I have to plug it into one of my equations. And it doesn't matter which equation you pick to plug it in. Oh, goodness. I'm going to pick the first one. 7x plus 5y equals 26. Again, it doesn't matter which equation. I'm going to plug in x equals 3 in for the x variable because it says x equals. And when I plug it in, I'm going to put parentheses. So 7 times 3 plus 5y equals 26. Now remember, we need those parentheses because if we don't have the parentheses, then it looks like 73. So 7 times 3 is 21. Then my next step here is I'm going to get y by itself, so I have to subtract 21 on both sides. So I get 5y equals 0. Oh, wait, whoops, not 0, 26. Here we go. Sorry, I wrote that wrong, so I copied it down wrong. So it should be 21 plus 5y equals 26. Then I subtract 21 on both sides, and I should get 5. Divide both sides by 5. I get y equals 1. Okay, so what does that mean? That means my solution is the point 3, 1. Let me just double check that. 21 plus 5, yep. And then -12. Yeah, okay. Number 3. Now, before you do anything, you check, is it in standard form? Yes, because sometimes it's not, right? So if it's not, we're going to have to move it. Excuse me. So let's check next. We're looking for the same number in opposite sign. Do I have the same number on a variable? Because I can either eliminate x or I can eliminate y. Well, I notice that my y's both have a 6, so they have the same number. But is positive 6 and positive 6 going to make 0? No, it makes 12, right? So we have a problem here. We're like, well, what do I do, right? Okay, well, I need an opposite sign. Well, there's something that I can multiply 6 by to make it the opposite sign. I can multiply this by -1, and it would make it -6. So with number 3, we can't just eliminate something because it won't eliminate, right? If I add, I get 12x plus 12y. And that doesn't help me because I haven't gotten rid of anything. So I need to get rid of something, but I have to do it by manipulating one of my equations. So I have to choose one of my equations to manipulate, and it doesn't matter which one. So I can choose to change the first one or change the second one. Okay, well, let's see here. It doesn't really matter which one I pick because they're both +6, and I need one of them to be negative. I need a +6 and a -6. So I'm going to choose to change the first one. In order to change it, I need to multiply everything by the same number. Now again, we're trying to get rid of y. So what's our goal here? We want to have +6 here, but we want -6 here. Well, what can I multiply by +6 to make it -6? -1. And so here I'm going to show you. We're going to multiply -1 by everything. -1 times 5x is going to be -5x. -1 times 6y is going to be -6y. -1 times 4 is -4. And you're like, whoa, did that change my equation? Like, I multiplied by something. Doesn't it change everything? Well, let's check with Desmos. I have 5x plus 6y equals 4, correct? Is this what we have? 5x plus 6y equals 4. Then I multiplied everything by -1. So I had -5x minus 6y equals -4. What do you notice about these two lines? They're the same. So when we multiply all of our terms by the same number, it stays the same. You can think about it like plastic surgery, right? We did some plastic surgery to our equation. Like when someone gets a new nose job, they're still the same person, they just look a little bit different. So this is still the same equation as earlier, it just looks a little bit different. Okay, and then you're like, well, now what do I do? Well, I'm gonna rewrite the second equation right underneath it just so that I have them stacked on top of each other. Because when it's stacked right on top of each other, it's easier for me to see. And then before you actually put your plus and table here, can you eliminate something? Yes, I can eliminate the y's now. So that's when I put my little plus sign, okay? So now I have -5x plus +7x, and that's going to give me 2x. Well, -6y plus 6y is going to cancel and become 0, and we have equals -4 plus 8, which is +4. So we want to get x by itself, so we're going to divide both sides by 2, and we get x equals 2. But this is not my answer, right? I need to pick an equation to plug it into. So let's just pick the first one. 5x plus 6y equals 4. All right? And now we're going to plug in our 2 in for the x. Whoops. So we have 5 parentheses 2 plus 6y equals 4. Well, 5 times 2 is 10. I'm going to get y by itself, so I subtract 10 on both sides. 6y equals 4 minus 10 is -6. Divide both sides by 6, I get y equals -1. So what does that mean? That means my solution point is 2, -1. Okay, so why was this problem different from the last two? Well, in the last two, there were already things that I could eliminate right off the bat. But if I can't do that, if I can't eliminate right off the bat, then I have to do some manipulation, some plastic surgery. And so for number 3, I had to do a little bit of plastic surgery so that I could do some elimination. Again, it doesn't change your equation as long as you multiply to every number. So if I took this -1 and I forgot to multiply it to the 4, then I'm changing it. You have to do it to everything. Okay, let's look at number 4. 8x minus 5y equals -20, and -4x minus 3y equals -12. Okay, well, the first thing we check for is it in standard form? Yes, my x's are there, my y's are there, and my numbers are all lined up. Okay, because we want to make sure everything is lined up so we can combine them well. Now, the first thing you want to check for is, do you have the same number anywhere? No, we don't have the same number. Do I have opposite signs anywhere? Yes. I have a +8 here and a -4. I have opposite signs. So in the last problem, everything was positive, but I had 2 of the same numbers. So I'm like, okay, let's get rid of y because that's the easiest thing to do. In number 4, we don't have the same number, but we do have opposite signs. So in this problem, the x would be the easiest thing to get rid of because it's already opposite signs. And if it's opposite, then there's less work that I have to do. These are both negative, and they're not going to cancel each other out, so we're going to have to do more work to get rid of those. So again, I'm going to pick the x's to get rid of here. If I want to get rid of my x's, I need them both to become the same number. Is it possible for me to get them both to become the same number? Well, yeah. I can get the first equation to be positive 8x. If I want that to be positive 8x, then what does this have to be in order for it to cancel? Negative 8x. So how can I get negative 4 to become negative 8? Well, I do some manipulation, and I can multiply this entire thing by 2. Okay, and so sometimes people ask, well, why don't you multiply by negative 2? Because you want it to become 8. But if I multiply by a negative, it changes the sign. Do I want to change this negative to a positive? No, I want to keep it negative because if I keep it negative, then the sign, they end up canceling, right? We want opposite signs. The only time you multiply by a negative is to change the sign. If you don't want to change the sign, then don't multiply by a negative. So why did I pick 2? Well, I just can't pick any random number, right? I have to pick a number that will make me match the other number. So since I have an 8 here, I'm trying to match the 4 to make an 8. So we're going to make negative 8. I can't just pick any number, right? Like I can't just multiply it by 3. It doesn't work. And when I multiply, you have to multiply to everything. So we have 2 times negative 4, which is going to be negative 8x. 2 times negative 3y is negative 6y. And 2 times negative 12 is negative 24. And then with that first equation, since I didn't do anything with it, I'm going to write it right underneath so that they're stacked on top of each other. Okay? And before I put my plus sign, I want to see, can I eliminate anything? Yeah, I can actually eliminate the x's now. So again, even if you can at the beginning, you might have to do some plastic surgery, and then you can eliminate something. So now I have negative 8x plus 8x. That's going to give me 0. Then I have negative 6y plus negative 5y, which is negative 11y, equals negative 24 plus negative 20, which is negative 44. And divide both sides by negative 11 to get y by itself. I get y equals positive 4. Well, how do I get the x? Well, I have to pick an equation. I'm going to pick the first one. So we have 8x minus 5y equals negative 20. Do I have to pick the first equation? No. Okay, and then we're going to plug in 4 in for the y because it says y equals. So we have 8x minus 5 times 4 equals negative 20. So we have 8x, negative 5 times 4 is negative 20. Trying to get x by itself, so I'm going to add 20 on both sides. So I have 8x equals 0, right? Negative 20 plus 20 is 0. X is still not by itself, so I got to divide both sides by 8. Well, what's 0 divided by 8? 0. So that means my solution is the point 0, 4. So it means that both of these lines are going to intersect at the point 0, 4. All right, moving on. Number 5. Excuse me. So here we have, first we check for standard form, and they're both in standard form. The second thing we check for is, do we have the same number anywhere? Well, I have 10 and 2, and I have negative 5 and negative 1. So not really, right? I don't have any same numbers. Do I have any opposite signs? No, right? I have, whoa, I just threw my Apple Pen. This is positive and this is positive. This is negative and this is negative. So now it's like, well, now what do I do? Well, you have an option here. You can either eliminate x or you can eliminate y. It doesn't really matter which one you pick. But I'm just going to go ahead and pick x, just because I want to, right? I can pick the negative 5 and the negative 1 if I want to, but let's go ahead and pick 10 and 2. So if I'm trying to get rid of x's, I need to know, well, is it possible for me to get these two numbers to become the same number? Well, I can't get 10 to become 2, but I can get 2 to become 10, right? So we're going to do some plastic surgery here. I need to multiply the second equation by something because I need that number to become 10. So what can I multiply by 2 to become 10? 5. 2 times 5 is 10. Now, if I multiply 5 times 2, I'm going to get positive 10. Is 10 and positive 10 going to cancel? No. If I have positive 10 up here, I need negative 10 down here. So how do I get 2 to become negative 10? I need to multiply by negative 5, okay? So in the last few problems, we haven't had to multiply by a negative number yet, except for in the first problem in number 3. The only time you multiply by negative is if you want to change the sign. So since my x here is positive, I need to change the sign. So I'm going to multiply by a negative. And I'm multiplying by 5 because I'm trying to get it to become 10. So we have negative 5 times 2x, which is negative 10x. Negative 5 times negative y is positive 5y, because that's a 1 in front, right? And then negative 5 times 1, which is going to be negative 5. And I didn't do anything to my first equation, but I am going to write it down so that they're stacked on top of each other. And before I actually put my plus sign, can I eliminate something here? Yes. So it's going to cross that off. Well, negative 10x plus 10x is 0. They eliminate. Positive 5y plus negative 5y is also 0. So what do I have on this side? I have 0, right? It's all gone. It's nothing. Nothing as a number is 0. And on the other side, I have negative 5 plus 5. What does that make? It makes 0. Does 0 equal 0? Yes. So what does that mean? It means I have infinitely many solutions because they equal each other. If I have 5 equals 5, or 3 equals 3, or negative 7 equals negative 7, all of these things equal each other. Since 0 equals 0, that makes sense. So we have infinitely many solutions. So what does that mean if I were to try to graph these two equations? It means if I were to graph them, they'd be right on top of each other. They're the same exact line. All right, number 6. So first thing you check for is standard form. It is in standard form. The second thing is do we have any same numbers? No, right? We have 5 and 6, and we have 15 and 5. Do I have opposite signs anywhere? No, right? So now we got to choose. Do we get rid of x or do we get rid of y? So now you got to think about this. Is it possible for me to get 5 to become 6 if I multiply by something? No. Is it possible for me to get 6 to become 5? No. So x is probably not the one that I want to eliminate because it's too hard right now, and we don't want to do hard work right now. We want to do the easiest thing possible. So let's look at the y's. Can I get 15 to become 5? No, right? I can't make it smaller. I can only make it bigger. Can I get 5 to become 15? Yes, right? I can multiply this entire equation by something to get 5 to become 15. Okay, so you all can always go up. You can never go down. You can only multiply. Well, since I have 5, what do I multiply by that to get it to become 15? I multiply by a 3. But both of these signs are positive, so they're not going to cancel each other. So if I have a positive 15 up here, I need a negative 15 down here. So 5 times what is going to give me negative 15? I'm going to need to multiply by negative 3. So negative 3 times negative 6x is positive 18x. Negative 3 times 5y is negative 15y. And then negative 3 times negative 22 is positive 66. And then the first equation I'm just going to write down. Make sure you always copy it exactly as is so you don't make a mistake. And then before you actually add, check to see if you can eliminate something. And in this case, I can. I can get rid of my y's. So 18x plus negative 5x is 13x. Negative 15y plus 15y is 0, cancels, equals 66 plus 25, which is 91. Now I want to get the x by itself, so I divide by 13, and get x equals 7. So x equals 7 here. And I'm not done because I got to pick an equation. And I'm going to pick the first one. So you have negative 5x plus 15y equals 25. And I'm going to plug this value in for x because it says x equals. So I plug in a 7 for that x value. Negative 5 times, in parentheses, 7 plus 15y equals 25. Negative 5 times 7 is negative 35. I need to add 35 to both sides. So I get 15y equals, I believe that is 60. Yes. Divide both sides by 15, and I get y equals 4. Sorry, I'm double checking. So I do get 4. So that means my solution point is the point 7, 4. All right. Moving on to number 7. So we have 2 problems left, just 7 and 8. So here we have 2 equations. They are in standard form, so that's good. The second thing I check for is, do I have the same number anywhere on my variables? No, right? Because I have a 1 and a 1 here. So I have a 1 and a 3 and a 1 and 3. So no matching variables. Or no matching numbers. Do I have any opposite signs? No. Now we check. Do I want to get rid of x or do I want to get rid of y? Well, I have the same numbers in both cases, so it doesn't really matter which one I get rid of. So let's just pick to get rid of x. If I want to get rid of x, I need my numbers to be exactly the same. Right now I have a 1 and a 3, right? So how can I get these both to become the same number? Well, I can have 3 and negative 3, right? I can make them become the same number if I multiply the first one by something. If I have positive 3 down here, how do I get 1 to become negative 3? Multiply by negative 3. Remember, we want opposite signs. So I multiply by a 3 to get to become the same number, but I multiply by negative to get that opposite sign. So negative 3 times x is negative 3x. Negative 3 times y is negative 3y. And negative 3 times 12 is negative 36. And then I'm going to write this equation below. And before I put my little plus, I want to make sure I can eliminate something, and I can. So go ahead and add those. Negative 3x plus 3x is 0. Those cancel, they eliminate. Negative 3y plus positive 3y is 0. So that also eliminates. So what do I have on this left side? I have a 0. Equals, well, what's negative 36 minus 6? Or negative 36 plus negative 6? Negative 42. Does 0 equal negative 42? No. So what does that mean? It means it's no solution. It means if I were to graph this on a graph, what's going to happen? They're parallel to each other. They never cross, so there's never a solution. Remember, 0 equals negative 2 makes no sense. So if it makes no sense, then it's no solution. All right, and then the very last problem we have is a word problem. So number 8 is Tom sells fish at his local market. He sold 2 small fish and 3 large fish in 3 hours. He also sold 4 small fish and 4 large fish in 5 hours. Write and solve a system of equations to find how long it took to sell each type of fish. Okay, so do we know how many fish he sold? Yeah, so the variables are not going to be the number of fish, right? We know the number of fish. So what are we going to make x? Well, the very last sentence tells us what we're looking for. It says to write and solve to find how long it took him. Well, if we're looking about how long, we're thinking about time. So since this is already talking about hours, we're going to call it the number of hours. Now, we can't just say the number of hours because we're talking about 2 types of fish here. We have small fish and we have large fish. So x is going to be the number of hours to sell a small fish. Okay? So that means y is going to be the number of hours to sell a large fish. Okay, we're talking about time here, so the number of hours. Well, let's look at our 2 equations. Well, I know that I have 2 small fish and 3 large fish in 3 hours. Remember, small fish is x, so we have 2x plus 3y equals 3. We have 2 small fish times however long it took plus 3 small fish times how long it took to equal 3 hours, right? The next equation is going to be, well, we sold 4 small fish and 4 large fish in 5 hours. So it's going to be 4x plus 4y equals 5. Okay, now we're going to solve. We're going to use elimination, right? Because our lesson over here was solving systems by elimination. So we don't want to use substitution and we don't want to graph. I'm going to go ahead and copy down the equations down here just so that I can see them better. Okay, so let's start. Well, I have my 2 equations, and I want to first check, do I have the same number anywhere? No. Do I have opposite signs anywhere? No. So let's look. Would it be easier for me to get rid of x or get rid of y? Well, it would be easier for me to get rid of x, and here's the reason. Here I have 2 and 4. I can get those to both become the same number really easily. But I have 3 and 4 here, and it would be really hard for me to get those to become the same number because I can't multiply anything by 4 to make it 3, and I can't multiply 3 by anything to get it to become 4. But with the x's, I have 4 here and I have 2. Well, I know that I can get 2 to become 4. So if I multiply this entire first equation by a number, I can get it to become 4. Well, right now I have 4x. Positive 4x. So I want the other one to be negative 4x. Well, what do I multiply 2x by to get it to become negative 4? Negative 2. We multiply by negative to change the sign, and we multiply by 2 to get it to become the same number. So negative 2 times 2x is negative 4x. Negative 2 times 3y is negative 6y. Negative 2 times 3 is negative 6. And then I'm going to write this equation right underneath it. So 4x plus 4y equals 5. And then before I do anything, I want to check to see if I can eliminate something, and I can. So negative 4x plus 4x is 0. That eliminates. Negative 6y plus 4y is negative 2y. Negative 6 plus 5 is negative 1. So I divide these both by negative 2, and I get y equals, well, negative 1 divided by negative 2 is positive 1 over 2, or 0.5. Now, this isn't my entire answer, but it's part of it. So let's talk about what y equals here. Well, y is the number of hours to sell a large fish. So how long did it take to sell a large fish? Remember, y is the number of hours. Well, what did we get for y? We got 1/2. So that means it took half an hour to sell a large fish. Do we know how long half an hour is? 30 minutes. So it took 30 minutes to sell a large fish, or half an hour. Well, now you're going to pick an equation to plug 1/2 into. So let's pick the first one. 2x plus 3y equals 3. Well, I know that y equals 1/2, so I'm going to plug it in here. So we have 2x plus 3 times 1/2 equals 3. We have 2x. Well, 3 times 1/2 is 3 over 2 equals 3. And then I want to subtract 3 over 2 from both sides because I'm trying to get rid of trying to get x by itself, not get rid of x. Well, 3 minus 3 over 2, I believe, is 3 over 2. I'm going to double check, though. Yes, it is. Well, now we're going to divide both sides by 2. So you get x equals 0.75, or 3/4. Well, what does x represent in our problem? X is the number of hours to sell a small fish. So it took 3/4 an hour to sell a small fish. Do you know how long 3/4 an hour is? Well, if a whole hour is 60 minutes, right? And half an hour is 30 minutes, let's break this up into 4s. What's half of 30? 15, right? So I have 15, 15, 15, and 15. So a whole hour, if I put 15 times 4, is going to be 60 minutes. Half an hour is 30 minutes, because 15 plus 15 is 30. But this is 3/4 an hour, so I have 15 plus 15 plus 15. So it's 45 minutes to sell a small fish, and 30 minutes to sell a large fish. So half an hour to sell a large fish, 3/4 an hour to sell a small fish. Or if you want to think about it, minutes, 30 minutes, and then 45 minutes. So that is it for elimination. Again, this is just another way to solve systems, right? There's graphing, there's substitution, and now we've learned elimination. So this is day 1. If you have any questions, please feel free to come in and ask.